Let's review the tragic accident of a Cessna 340 in the San Diego, California area earlier this week. The pilot was killed, a person was killed on the ground, and 2 people were seriously injured. This accident's gotten a lot of attention, so we thought we'd help you understand what's known about the accident at this stage and where the investigators are likely to look. Just a quick summary of the accident itself. A Cessna 340 flown by a single pilot from Yuma, Arizona to Montgomery Field, San Diego. During the descent phase of the flight, the pilot is cleared for runway 28 right approach into Montgomery Field, circle to land runway 23. During that approach, he's vectored off because he never intercepts the localizer. And in that vector back around for a second attempt, the pilot loses control and crashes into a nearby neighborhood.
Air 22 Golf, turn left heading 210, descend and maintain 3,800.
3,800, 210, 2 Golf.
Air 22 Golf, turn right heading 250, join final.
250, join final for 2 Golf. And 2 Golf, do you say clear for the ILS to it, right?
Air 22 Golf, you're 4 miles from Penny, descend and maintain 2,800 until established on the localizer. Cleared ILS, runway 28 right, circle to land, runway 23.
Clear for the ILS to it, right? For runway 23, 2 Golf.
Yes, sir. Descend and maintain 2,800 until established on the localizer.
2,800 till established on the localizer, 2 Golf.
Air 22 Golf, traffic 2 o'clock, 3 miles southbound, 5,000 descending, 4,000 to C-130. They are restricted above you. Caution, right turbulence.
Copy, 2 Golf.
Air 22 Golf, looks like you're drifting right of course. Are you correcting?
Correcting for 2 Golf. Is 2 Golf clear for runway 23?
22 Golf, you're not even tracking the localizer. I need you to fly. Actually, cancel approach clearance, climb and maintain 3,000. 22 Golf.
3,000, 2 Golf.
Maintain 3,000. Low altitude alert, minimum vector altitude in your area, 2,800.
Climbing 2 Golf.
Air 22 Golf, climb and maintain 3,800.
3,800.
Air 22 Golf, turn right heading 090, re-vectors to final.
090, 2 Golf.
Air 22 Golf, turn right heading 090, climb immediately, maintain 4,000.
1,000, climbing immediately, 2 Golf.
Okay, it looks like you're descending, sir. I need to make sure you are climbing, not descending.
Golf is climbing.
Air 22 Golf, say altitude.
2,500 to the Golf.
Air 22 Golf, low altitude alert. Climb immediately. Climb the airplane, maintain 5,000. Expedite climb. Climb the airplane, please. Air 22 Golf, just level out the plane, or the heading, and climb the airplane up to 5,000 when you can, sir. 10 o'clock and a half mile, 1,500. You appear to be descending again, sir. Are you, say altitude? Cessna 7022 Golf, SoCal approach.
So let's take a look at the factors that the investigators will look at as they try to determine the cause of this accident. Starting with the pilot. The pilot was highly experienced in this airplane. This was his airplane that he had over 1,000 hours in. Commercial, IFR rated, flying on a Class 1 medical. He lived in the San Diego area but commuted to work in Yuma, and he bought this airplane in part to help with the commute back and forth from Yuma to his home in San Diego. He'd flown the airplane, it appears, about 19 times since September 1st, and flown this exact route 5 times, and flown the other direction 5 other times. So he's very familiar with the airplane, very familiar with the route, and it appears he was proficient. The Cessna 340 is a capable airplane made for this kind of flying and this kind of commuting that the pilot was using it for. The fuel systems can be tricky. The tip tanks are the main tanks on a Cessna 340. Auxiliary tanks are inboard of the tip tanks, and managing the fuel between the auxiliary and the tip tanks and how that's burned is important and can affect the handling characteristics of the airplane. The NTSB will certainly take a look at fuel management as best they can, given the destructive nature of the crash. That'll be difficult for them to do. Avionics-wise, it was upgraded with Garmin avionics to include a Garmin GFC 600 autopilot. The pilot was known to take meticulous care of his airplane and spared very little expense in the upgrades to both the engine, the avionics, and the interior. Conditions for the flight, En route weather at cruise, the winds were out of the northwest and pretty strong, 40 knots or more. Based on flight-aware tracking, we can see some erratic airspeed control at cruise, which likely indicates the pilot was experiencing some turbulence at cruise. And on the VFR chart, about 30 miles northeast of the accident site, there's a caution for pilots to be aware of the potential for severe turbulence in the area. Based on the winds and the changing direction of the winds, both at altitude and in the descent, it's very likely the pilot was experiencing at least moderate turbulence and experiencing some challenges maintaining course with wind direction that was requiring him to constantly update his heading. This was likely quite disorienting during the descent for the pilot. ATC advises him of his approach plan about 24 minutes prior to his descent.
November 7022 Golf, checking in 10,000, information is here, Montgomery.
Flight Cessna 7022 Golf, scout approach, vectors ILS, runway 2 right at Montgomery, and expect runway 23.
We'll expect runway 23, vectors for the ILS for 28 right.
He's told to expect an ILS to runway 28 right at Montgomery Field, circle to land runway 23. A circling approach is certainly more demanding than just a normal approach. This circling approach was only involved about a 50-degree offset from runway 28 to offset to land runway 23. In essence, he would fly on ILS approach to runway 28 and then break off and report a left base and land runway 23. This circling approach seems to be a real key to understanding the cause in this accident. The pilot never seems to fully grasp the ground track that he'll be flying for this approach, and his situational awareness begins to erode rapidly. Once starting his descent, the pilot is given 5 altitude step downs and 3 heading changes within about a 5-minute time span. Manageable, but certainly things are starting to increase. The pilot's communications with air traffic control, his tone of voice and his pace seem normal until the latter stages of the descent.
Clear for the ILS 28 right, for runway 23 to Golf.
As he's descending in to intercept the localizer to runway 28 right, he never does intercept the localizer and requests to transition to runway 23. During this phase, he's very likely popping in and out of broken clouds, with bright sunlight going to dark clouds. And again, remember, there's very likely turbulence throughout this. So all of this can be disorienting. Turbulence among in and out of VMC to IMC conditions is much more difficult than just being in straight IMC or straight VMC. He doesn't intercept the 28 localizer and begins to show signs of being a little bit flustered. He requests to transition to runway 23. ATC denies that and advises him that they're going to vector him back around and attempt another approach. So in essence, ATC can tell that the approach is somewhat erratic. They're going to vector him back around to intercept the ILS to 28 again and try the whole procedure again. But during this vectoring is when things really begin to erode. The pilot's airspeed control is erratic, changing by upwards of 60 knots or more. His altitude control is also erratic, changing by 600 feet or more during a short time span. And in that continuous right-hand turn, approach advises the pilot multiple times to climb. They're worried about him heading towards the mountains to his north in that right-hand turn. The pilot acknowledges these and at one point indicates that he thinks he is climbing when in fact he never is. He continues the turn, breaks through the bottom of the clouds, and when we see him on cameras, he's in about 80 degrees of bank and impacts the ground about 50 degrees nose low. The latter stages of this, both the pilot thinking that he's climbing when he's not, ATC constantly urging him to climb, and a high airspeed, high angle of a bank, are what seem to indicate a loss of control by the pilot and potential for spatial disorientation. So based on that recap, let's take a look at where the investigators are likely to focus. In this case, they'll look at the pilot's experience level and they'll look specifically at his experience in IMC conditions. While he had a lot of time flying this airplane in this region of the country, in this region of the country, weather is typically clear. So how much actual IMC time did the pilot have, and whether or not that lack of experience could have contributed to spatial disorientation is certainly a place the NTSB will look. They'll also look at systems failures, including avionics. A failure in avionics can cause severe disorientation in pilots, especially if it's a partial failure or if it fails without warning. The NTSB will also look to determine if both engines were operating fully throughout the flight. In a light twin engine, if one engine is not fully operational, it can impact the handling characteristics of an airplane, especially in the final phases of flight during an approach, which can make it challenging to control. Even though this impact was severe, the NTSB will likely be able to determine if both engines were operating and whether or not that impacted control of the airplane. The NTSB will also look to affirm airframe integrity. Because of the METARs in the area, the forecast for turbulence, during a descent, it's possible that severe turbulence can impact the flight controls of an airplane and potentially even cause a departure of some kind of flight control or another. The NTSB will try to determine this to see if that was potentially a cause of why the pilot lost control of the airplane, if there was any damage done to the airframe itself. When the final NTSB analysis of this accident is complete, we'll update you. In the meantime, follow us for more accident analysis and safety education that'll help make you a safer pilot.